Today, we are going to solve a famous LeetCode problem named house robber. Before telling you the final solution, I'm going to give you some hints. Then we are going to discuss about the solution and how can we get to solution. And then I'm going to implement the problem and we are going to get accepted, hopefully. Here's the problem. Also, the problem link is on the description, or you can search it yourself on your browser, house robber LeetCode. And without further ado, let's get into the problem. You should pause the video and read the problem very carefully. Then we are going to discuss the examples and solve them together to make sure you understood the right version of the problem. So as you might understood, the problem says simply you are given an array of n integers. You should choose some elements of the array such that their summation would be as maximum as possible. But there is a condition here. You cannot choose any two adjacent elements. So let's get into the first example. In the first example, we have an array of length 4. The first element is 1, 2, 3, 1. So what is the optimal solution here? Of course, is to choose 1 and 3. And their summation is 4. Let's also talk about an invalid solution. You can't choose these 3 elements because these 2 are adjacent and also these 2 are adjacent. So for the first example, the answer is 4, and the optimal solution is to choose these 2. Let's get into the second example. We have an array of length 5. So let's say we are going to choose 9. Then we can't choose 7 and 3, but we can choose 2 and 1, and their summation is 12. Or if we are going to choose 7, then we can't choose 2 and 9. And between these two, we can choose only one of them. So we are going to choose 3. But in this solution, the answer is 10, which is less than our previous answer, which was 12. So before I'm going to tell you the final solution, you should pause the video and think of the problem about 1 hour. And then I'm going to give you the first hint, which is the problem tag. And then we are going to solve the problem together. So please pause the video and get back after you have thought for the problem for about 1 hour. Here is the first and only hint for this problem. Think of DP or dynamic programming to solve this problem. Okay, I hope you've put enough time on the problem, and now we are going to talk about the final solution. Okay. After investigating some definitions for your DP, you might came to this definition, which is very common in DP problems, and that is DP of I would be the answer for the first I element of our initial array. So for example, for the first example, we had 1, 2, 3, and 1. Here is the exact definition of our DP or dynamic programming. DP of I is the answer for the first I elements of the array. And what do I mean by that? For example, DP of 2, what does it say? It says that consider we have only the first 2 elements of our array, or only the first 2 houses, and we are going to rob from them, and we want to get the maximum value we can. So for the first 2, we cannot choose both of them because there was a constraint on the house we are going to rob. So we only can rob from one of them, and the optimal solution is of course to rob from the second house. So DP of 2 would be 2. DP of 1, it says that consider we have only the first house. So you should forget about other houses. And okay, we have one house, we want to get maximum value from it, so we are going to rob from it. So the answer would be 1. dp of 3 says we have only the first 3 houses, so forget about 1. Okay, now we want to rob 3 houses. Okay, so the optimal answer is to rob from the first and the last house, or the first and the third house, which is going to give us 4. And dp of 4, it says that consider we have the first 4 houses. It means that consider we have our initial array. So dp of 4 is exactly the answer for this example. And we know that dp of 4, or the answer to this example, was 1 and 3, which is 4. Okay, so we have our definition of dp, but there are something remains. And that is, how are we going to compute dp of I in terms of previous i's? Okay, so let's consider the first I houses. 1, 2, 3, I minus 1, and I. Okay. We only have 2 possibilities. Either we are going to rob from house number I, or we are going to not rob from it, or ignore house number I. So we have only 2 possibilities. We should find the answer in each possibility and get the maximum. So for the first possibility, if we are going to rob from the last house, or house number I, then so we are going to choose it. So for now we have ai values, because the value from this house is a of I, and a is our initial array. So if we are going to rob from the last house, then from the problems constraint, we know that we cannot rob from this one. So we lost house number I minus y. But now look into our new problem. We have the first I minus 2 houses, and we can rob from them, from each of them. But again, we should take care of our constraint, which was do not rob from any 2 consecutive houses. So this is exactly the definition of dp of I minus 2. So the first case is going to be ai plus dp of I minus 2, because we chose house number I, and also from these first I minus 2 houses, we want to get the maximum value with the problems constraint. And if you look at the definition of dp from the previous page, you will know that this is exactly the number dp of I minus 2, which is already calculated. Okay, now let's get into the second possibility, which is if we ignore house number I, what happens? Pause the video and think of the value for this possibility. Okay, so if we are going to ignore house number I, then what remains? We have only access to the first I minus 1 houses, and we want to get the maximum value from them with the problem constraints. And that is exactly dp of I minus 1 and nothing else. So yeah, we got a relation for our dp in terms of previous dp's, which is maximum of ai plus dp of I minus 2 and dp of I minus 1. Okay. Now let's talk about basis steps, because every dp problem should have some basis steps. For this problem, the basis step is very simple. It is dp of 1. dp of 1 says that consider we have only the first house and we want to get maximum value from it, or rob maximum value from it. Okay, if we have only one house, and due to the problems constraints, we know that all houses values are positive. So we are going to rob from the first house. So dp of I is simply ai, or the value we can get from the first house. Okay, there is only one step remains. Let's say that we already computed all dp values. What is the final answer to the problem? As I mentioned before, implicitly, the final answer is dp of n, where n is the length or size of our array. And why is that? Let's review the definition of dp of n. dp of n says what is the maximum value we can rob from the first n houses with the problem's constraint. And remember that the problem's constraint was that we can't rob from two adjacent houses. Okay, now what is the first n houses? What does it mean? It means exactly it is equivalent to the initial array, or the given array, or the array on the input. So it says that the maximum value we can rob from our initial array with the problem's constraint. This is exactly the definition of dp of n and the problem's answer. Now I think we've got everything needed to solve the problem. So let's go into the implementation. I'm going to use LeetCode editor to accept the problem. The first thing I'm going to do is to get size of our array, or the number of houses. Remember that in my explanations I was going with a for the name of our array, but here LeetCode uses nums, but we can change nums to a to be consistent with our explanations. Okay, now the next thing is to define a dp array. I'm going to choose n plus 1 for its size because we discussed about dp as an array of 1 based index. So dp of I was the answer for the first I houses. So we should return dp of n, because dp of n would be the answer for the first n houses, which was the answer to the problem. Now, how about basis steps? So dp of 0, I actually forgot to talk about dp of 0 for in the explanation. It is necessary. dp of 0 says, let's say that we have no houses. So the final value we can get from no house would be 0. dp of 1 says that, let's say that we have only the first house. So the first house's value is a of 0. So dp of 1 would be a of 0. Then we are going to have a for loop from 2 to n. And dp of I, as I mentioned in the explanation, would be maximum of dp of I minus 1. This is the case that we are going to ignore the ith house. And dp of I minus 2 plus a of I minus I. This is the first possibility, which was to rob from the ith house. And yeah, that's it. Let's test our solution. And why do we need two basis steps? Why cannot choose only one basis steps? Because here, if you see, we are using two previous dp values, dp of I minus 1 and dp of I minus 2. So the number of basis steps you need, it depends on the number of previous dp's you are using in calculating each dp state. So if we were using 3 previous dp values, we needed then 3 basis steps. But this is not the case. So let's just run for the examples. Okay, we've got accepted on examples. Let's run the solution for all tests. Okay, we got accepted. So yeah, thanks for watching us. If you are still here, please don't forget to like, subscribe, and ring the bell. See you on next videos. Bye bye.